Hello and welcome to this new video. Today we're going to present how to evaluate and interpret the prediction of a model in papAI. To do this, we're going to take a classification model that is already trained and we're going to present its results. We will first access to the Titanic project. We used it for a previous cleaning module video. The flow contains the Titanic dataset that was imported from a CSV, a cleaning step, its output that contains 16 columns, and the target columns, survived, with 0 for not survived and 1 for the positive class survived. We have here a machine learning lab that is already created with a binary classification use case for survival prediction. Some models are already created, and we can see here their result based on multiple metrics like accuracy, F1 score, precision, and so on, to choose the best model. We choose the one with best results and we take a look at its evaluation. Here we can see the metrics table with accuracy of 0.85, and on the right we have the confusion matrix. We can also change the probability threshold here to see how the metrics are changing and keep the best threshold. We can have an idea also about its best value from the density chart here that displays the probability distribution. The RAP curve is presented here that shows the true positive rate against the false positive rate. You can also see what is the best threshold from this decision chart in the bottom. It displays how the metrics of the metrics table are changing in function of the threshold. The second tab in this screen is for model interpretation. Here we see the importance of each feature by descending order, sex, then PC class, then age, and so on. And for each feature, we have its spatial dependence plot that shows the target probability evolution in function of the feature's values. If sex is female, this person have more chances to survive than male. Male have a very small chance of survival, less than 25%. The PDP of P class shows that first class have higher survival chance, then second class, then third one. Regarding age, children under 10 years old and persons of more than 70 years old have more chance to survive compared to other ages. Title is like sex. We see that Miss and Mr. have more chance than other values. Regarding other features, like family, number of siblings, spouses abroad, and parent-children, the plot is decreasing, which means the more you have people on board with, the more your chance of survival is decreasing, but with a slight slope. Another method of interpretability is proposed. It's called tree surrogate. This method tries to display any model under the form of tree branches to explain the decision process. Here, for example, this first split is based off the value of sex. The big part of 68% accounts for males and the majority is on class 0. The second condition gets us on a branch of 100% on class 0 if age is greater than 9.5 and sex is male. Heading to the flow now. After the creation of the model here in the ML lab, we used it to do the prediction. And we have a prediction output here. It has the real survival column and the predicted one. Here in first row, for example, both are 0. Here there are 1 in the second row and so on. Let's click on one prediction here and interpret it locally to see why this prediction is 1. As we see, the prediction is 1 with a probability of 0.85. But the most important part on this screen here is the feature contribution plot. The features in blue impacting positively the prediction and red color negatively. Let's take another row with negative prediction and interpret it. Here, sex is male, P class is 3 and title is Mr. So this is why it's negative. Let's try one of our features called simulation of type what if. Let's change the value of some features here. Putting sex as female, title to Miss, and small age, let's say 5, and test changes. The predicted class is 1 because of age, that is 5. P-class is always red because it's always 3. Then we can reset the form to its original value. Last interpretability method that we are going to present here is very useful in multiple use cases, and it's called Counterfactual Explainer. Here we choose a desired class that we want to have as output. We choose the features to vary. Let's keep just the first 3 features. We can even select the range of value of these features, and we click on Compute. This will propose through a genetic algorithm what we can change from the value of the 3 features to have the class 1 as output. Let's check this to see only the values that are changed. So for example, it says that if on our actual row sex was female and age was 7, our output would be different. It gives the best proposition only. Here it gave us 5 propositions because we asked for 5, but we can put more.